As promised, here is some guidelines and a review for those of you who need to learn to use your calculators efficiently, both to do vector problems and to do simple calculations like Bernoulli energy loss calculations. First, be aware of your mode settings. It's not just about looking at the tangent of 45. It's about knowing whether you are graphing in polar, whether or not you want to have how many numbers you want to have in your float, whether you are graphing parametric or polar, or whether you are graphing simultaneous or sequential in terms of the time that your graph goes across. It's about being aware of your window settings, both in regular mode, parametric mode, or polar mode. Remember to not necessarily keep a lot of data in your list 1 through list 6, which are somewhat used for doing stats plots, statistical plots. Learn to use them because they're easy to get at, and then transfer the data to another list using the stow command or store command. Keep your stat plots off until you need them. This will avoid problems like having an unmatched dimension come to your screen. If you are using lists, keep the float number set in the mode screen pretty low so you can see the list on the screen. And remember, as much as possible, to keep the X graphing range 1.5 times your Y graphing range. This makes it so your eye does not get untrained from knowing what in fact is a normal shape of a function. So, buttons that you should eventually wear out on your calculator. The window function. It's telling lots of stuff about what you're going to do when you graph. Be active in its use. The mode function. Obviously, the first time you turn on the calculator, you're checking that. Stat plots and functions for actually doing the graphing of things like statistical plots of data. Station and elevation would be one, and then functions, for instance, the energy grade line. Stat and list functions so that you can actually efficiently get data in and out. And finally, that stow button, which forces information from one variable to another or from a number or a text to a variable. Remember to learn to use parametric and polar graphing of functions, not just the normal old standard function graphing, and to learn to use the simultaneous mode. Be aware also that if you are doing those, you not only need to worry about the X and Y ranges, but also the time or the theta ranges. Especially be aware when you're doing these graphs whether or not you have set your data to radians or degrees. Typically, if you're doing polar graphing, you are thinking in terms of radians. You have now been provided more than enough programs so you can look around and see especially how matrices and lists work. GNU is the open source world, and we're beginning to see some programming by some others with super unit names. This may seem silly, it probably is, but not as silly as carrying around a calculator for 2 years and not learning how to program it. If you have good eyes, you can put more stuff on the screen using text with a location than you can with output. But many of us, we ain't got good eyes. You use clear home a lot and other clear functions so you can keep your screen clear. You also I often tend to use the bottom row 8 for the question and then deal with the input farther up in the screen. Kind of like you see with AutoCAD in the command line. And finally, since lists are the only data structure that you can add long names to, it's a good idea to learn to use those as some of your variables if you're writing especially an extensive program, so you can make something out of your code. That said, here are some insights into the hodgepodge of programs provided up to date. First off, these programs mostly deal with an inability of the TI-83 to deal with standard engineering notation or vector notation. The program has an ability to go between rectangular and polar coordinates, but not using standard commands to get into X, Y, and Z. The Coordinate Convert is a great program because it stores both your polar input and the vector output, or vice versa. And it is perfectly reasonable to use the Coordinate Convert to kind of pre-populate V1, in other words, the vector in the standard notation, and then force it over to list U or list V using the store command to transfer from V1 to U or V. This vector program was adjusted from the internet, so it has not been completely worked, but it has been tested time and time again. And it's used for and been adapted from the internet so that in the end you'll be able to keep track of not only the sums of forces, but of course the sums of moments. Those, I believe, are stored in matrix B. Remember that the vector product, which is stored in list W, has both magnitude and direction. A scalar product just has sense. It is also perfectly normal not just to use the skip input part of the vector program, to just use the vector program to do lots of calculations like magnitudes and angles in between scalar products and cross products, where in fact the vector product is stored in list W. The magnitude of the vector product is what is reported by area in that calculation. And then by learning to transfer list W back and forth to list U and list V, you can do some pretty substantial engineering problems. To get the fall line, in other words, down the face, you take the cross product of any two vectors in the plane that gets you the normal vector. You multiply that by the gravity vector, and then you take what comes from that and multiply it once again, cross product, by the normal vector. That will get you the down face or the fall vector. Finally, it's important at this point to learn just because you're doing things on a calculator does not mean you need to develop them or maintain them on your calculator. I highly suggest those of you who have invested in this calculator go out to Texas Instruments and get a hold of TI Connect. While graphing data on this calculator does not remotely compete with SketchUp or AutoCAD, it does provide you a very quick way, once you've learned to do the calculation, to see that in fact some of what you're doing does actually look the way you think it looks. It does not compete with the 3D of SketchUp or AutoCAD or any engine like MicroStation or 3D VIA from Microsoft. And as I head to the next short video, you can see here the screen. Remember that these menu programs are just ways to force you to other parts or other pure programs. Menus are just kind of a way of kind of forcing you to one place or the other in the program. Vector and Coordinate Convert can complement each other, along with the W United program, which takes the W vector and makes a unit vector out of it. And eventually you'll see that Transform does coordinate transformations for vectors as well. It has a big disclaimer on it now. It is mostly correct, but it has slight errors. But it does allow you to look at how you deal with matrices in a program. That's the end.